Oh, gravity, your force on me is m times g. Okay, gravity, let's try it. So what is gravity? Gravity is a force of attraction between two objects with mass. It's one of those field forces that we talk about. It acts over a distance, doesn't necessarily have to be in contact. The strength of the attraction between those two bodies are based on the mass of each body in kilograms, the distance between the bodies in meters, and this thing called the gravitational constant, G, capital G, notice it's a capital G here, equals 6.67 times 10 to the negative 11 newtons times meters squared over kilograms squared. So that's the unit, it's a big unit. And that's the formula. Fg is equal to capital G, m1, where that stands for the mass of the first body, m2, the mass of the second body, over r squared, where r is the distance between them. The reason that we use r for a distance here rather than d or x is that we think about the universal gravitational law in terms of orbiting bodies. Any position around the sun, for example, would be equal to a radius. So that's why we use the r term here. So, gravitational proportions. The force of gravity is blankly proportional to the mass. Yeah, that's directly proportional. So if the mass of one object is doubled, the force of gravity is doubled. And if the mass of both objects were doubled, the force of gravity is quadrupled. So in terms of the force of gravity, it's blankly proportional to the blank of the distance between them. And that's inversely proportional to the square of the distance between them. It's in fact the first inverse square law that you'll learn in our class. If the distance between the object is doubled, the force of gravity is 1/4 as great. And there are other inverse squares, magnetic force, electric field force, light intensity, sound intensity. They all work on the inverse square principle. If I were to triple the distance, the force of gravity would be 1/9 as great. Yay, because it's an inverse square. So 3r squared would be equal to 9r squared, so 1/9 of the force of gravity. So let's try some examples here. We said this one already. If we double one mass, we double the force. If we double both masses, 4 times the force. What if we triple one mass? Well, let's triple the force. How about if we triple both masses? That's right, 9 times the force. If we half one mass, it would be half the force. And if we were to half one mass and double the other, well, it'd be the same amount of force, 1x. And this is very commonly the way that Regents ask questions on these kinds of problems, rather than actually having you calculate the force of gravity. Let's try it with distance. We double the distance, we said that was 1/4. We triple the distance, we said that was 1/9. What happens if we half the distance? Yeah, that's right, it's 4 times as much force, because 1/2 squared is 1/4. Quarter the distance, and we get 16 times the force. The closer we are, the greater the force of attraction. Let's combine them, shall we? Double one mass and double the distance. 2x times 1/4 x equals 1/2 x. How about doubling both masses and doubling the distance? Well, 4x times 1/4 x equals 1x. Half one mass and half the distance? Yeah, 2x. Triple one mass and quarter the distance. That's 48x. So, here's an example problem. Let's try it. We have 2 asteroids here in a gravitational relationship with each other. The mass of the first one is 4 times 10 to the 5th kilograms, and the mass of the second one is 6 times 10 to the 5th kilograms. The distance between their centers of mass is 3,000 meters. So what is the force of gravity between these two bodies? Yeah, 1.78 times 10 to the negative 6 newtons. Again, using the gravitational formula. Finally, let's look at gravitational fields. Objects with mass produce a gravitational field, and the field lines point inward from all directions. So that's the gravitational field around a body. And here's the gravitational field around two